Hello, this is Mr. Zanolletto. I'm going to review classifying triangles by side length. I think this is a review to many of you. Equilateral triangles, all three sides lengths are the same. Isosceles triangle, at least two side lengths are the same. And scalene triangles have no side lengths are the same. We're going to continue this thought. The notes we had when given the coordinates of each of the three vertices of a triangle, we first have to find the lengths of the three sides using the distance formula. And then we go ahead and classify one of these three. So our first example as we review this is as given here. Example 1, classify triangle ABC as an equilateral, isosceles or scalene triangle. Vertices of a triangle ABC are 2, 5, 6, 2, and 3, 6. So first off, I'm going to go ahead and look at those first two vertices. I'm going to say AB then would equal the square root of 6 minus 2 squared plus 2 minus 5 squared. That gives us square root of 6 minus 2 is 4 squared, and 2 minus 5 is a negative 3 squared. Now as we work with this, we have square root of 16 plus negative 3 squared is 9. So that's square root of 25 is 5. So AB has a length of 5. I'd go on and go to find AC. AC will equal 2 minus 3 squared and 5 minus 6 squared. Remember, the order is really not going to make a lot of difference because here, when once we get done with it, we get negative 1, we square it, it's going to be positive regardless of whether that's negative or positive. 5 minus 6 is a negative 1 again. We have square root of 1 plus 1, which is a square root of 2. I'm going to leave it as that so it's exact. And then my last one, I have BC. It's going to equal the square root of 3 minus 6 squared plus 6 minus 2 squared. Let's see, make sure you can see that. So we end up with negative 3 squared plus 4 squared, which equals the square root of 9 plus 16, which is the square root of 25, and once again that's 5. So we do have two of them. Two of these lengths are the same. Therefore, since these two are the same, triangle ABC is an isosceles triangle. So that's example number 1. Again, we just break it down and see that when we use the distance formula for each going from A to B, A to C, and B to C, we end up with 2 being the same, so that's isosceles triangle. Let's look at another example. We have classifying triangle XRT as an equilateral, isosceles, or scalene triangle. Again, we're going to break this down into 3 parts. XR would equal the square root of 7 minus 3 squared plus 5 minus 2 squared. That's equal to the square root of 4 squared plus 3 squared. Similar numbers. 16 plus 9 is the square root of 25. So XR is a length 5. Let's go ahead and do XT. Would be the square root of 2 minus 3 squared plus 17 minus 2 squared. That gives me the square root of negative 1 squared plus 17 minus 2 is 15 squared. That equals the square root of 1 plus 225, which is equal to the square root of 226. Clearly these aren't the same, so we have two different values. Let's go ahead and leave this as it is. We might be able to simplify that. I'm going to go ahead and just go with this. We're trying to find out whether they truly are any common ones. If there's not, if they're all different, I think it'll become apparent even if I leave that. So I have RT. That's going to be 2 minus 7 squared. Length of segment RT would be 2 minus 7 squared plus 17 minus 5 squared. So that equals 2 minus 7 is a negative 5 squared plus 17 minus 4 is 12 squared. Simplify that, I get 25 plus 144, which is equal to the square root of 169. Put that in your calculator, you should get 13. So we have 5, a 13, and a 226. Square root of 226. No, 4 won't go into that. We're good. So all three are different. Therefore, triangle XRT is a scalene triangle. And that would be my final answer. So there's two examples to carry you through the concept of classifying the triangles given coordinates for their vertices. Thank you.